so this is me. Shout out to NumFocus because they do not only PyData, they actually sponsor a lot of the numerical work that gets done everywhere. All right, so are there any books on Julia? Yes, lots of books. You can get a lot of them online for free, more or less. NumFocus, right? Here we are. We're in Julia. And here's Julia over here in Jupyter as well, as is the R for R. Okay, so I think there's 0 R talks, so I feel like I'm ahead somewhere, right? But I've been working with Python for quite a while too, so. And I started with Fortran. So I go way back in terms of numerics. Let's see if this works. There we go. All right, so this is not for beginners. The learn, is there? Yes, there is. Here we go. Probably doesn't help much in the second row. Okay, this is a very cool book, and if we have time, I'm going to be looking into it. Okay, there's a talk given at JuliaCon. By Michael, and it's really a great talk, and it has lots of examples of Julia built right into the textbook. All right, so does anyone know who is not one of the creators of Julia in this picture? It's Kino. Okay, but the other 4 are the creators. These are actually the co-founders of Julia Computing. So the founders, the creators of the language, a few years later decided to form their own company. All right, so there are blogs out there. They're pretty good. The bottom one's going to be a little more commercial, of course. The top one has some really cool kind of stuff, mostly in Julia. Online courseware, plenty of that. This is from Cape Town University. And it uses a Jupyter notebook to present the course. So it works quite well, and it's free unless you want a certificate, which costs a little bit. Okay, so this was 2 weeks ago, and it was a great turnout, lots of stuff happening. Fernando Perez, Mr. IPython himself, gave a keynote. And here are some of the talks. David Sanders, a great tutorial. And the title, moving towards version 1.0, right? Julia, right here, is at 0.6. That just came out 4 or 5 days ago, June 27th. And be forewarned, there are some things that broke from 05 to 06. The promise is, though, that nothing will break going from 6 to 1.0, which is the next scheduled release. Nothing will break in the sense that if it isn't already deprecated now, it won't be deprecated later. All right, but all the deprecation warnings will be taken out. Okay. And a few more talks, machine learning, of course, and homomorphic encryption, which is very compute heavy, right? Nice talk, and there are many more. And these are now available on video. Okay. Okay, so here's a use case from a couple years back, the FAA. Next time you fly, keep this in mind. Try to have positive thoughts about software. Okay. There's a great website about the 10 major failures in the physical world caused by software. The Ariel 5 rocket's a great example, but that's another talk. Okay, so let's look at some of the differences between Julia and Python. On the Julia.org website, they also give you differences between Julia and MATLAB, Julia and C++, but this is probably the most relevant here. The things that you either love or hate about Python, you'll either love or hate about Julia, possibly at the same time. So indexing starts at 1 rather than 0. And this piece here, which for those of us who are used to closed set notation, it feels a little more natural to include both 2 and 3 as the last element. Okay, so the last element here is included. Here is the next to the, right, the one less than. Right, we all know that from the way that slicing works and ranges. Okay, and you don't have any negative indices, a very cool -1, -2, -3 part. In Python, well, you have end as a keyword. Okay. All right, so the end also gets used in the blocks. Right, there's indentation, not so much, right? Indentation really doesn't matter. White space here and there does matter. You know, you sometimes cannot put a blank space between things. You'll discover that. And it just does the same sort of thing the many languages do now. If it thinks there's more to come, it'll wait. If it thinks it's done, it's done. So if you put your plus sign on the second line, it won't look for it. Right. All right, so I hope this is visible to the people in the 10th row, which is what I geared this for. So here we have a small difference in how the modulo operator works. It comes down to here you have -1, and here you have +2. It's the remainder versus modulo. The results are pretty much the same for positive numbers, but it can be a gotcha if you're depending on a particular behavior. So here's version 0.6.0 and 3.61. So there are some differences between Julia and 2.7. You're pretty much on your own for that, I think, by now. Okay, so this is a fun one. Not only did Python change integer division, there's always been this double slash available in Python, right? That says, I really want you to do integer arithmetic here. The difference is that Python will give you that integer result for the double slash, whereas Julia will give you a rational. And you can see it operating over here with 7/4 plus 4/7. I may have put an extra blank in there just for visibility, but the 2 slashes should go right next to each other. And you get 65/28, which is useful for some applications, right? If you really need rationals, you get them automatically. Now, you can convert rationals to integer. This is part of the very convoluted, intricate type system that we all deal with in one way or the other. Duck typing or not, it's hard to avoid caring at sometimes, just what you have. So here we can convert a rational number to an integer. That kind of makes sense. But you can't really, not all cases get taken care of for you automatically. So if you're doing integer division and one of the numbers is a float, Julia is going to squawk. So apologies if the red on blue is a little too contrasty back there. But it does let you know that there's an error, and it gives you some suggestions as to what you might use. So there's this notion of multiple dispatch, which means that you can run Julia without caring about types at all, or you can care very much. Why would you want to care very much? Generally for performance, for time performance. Just like NumPy and Numba and Python look underneath the hood and try to really take advantage of what's known about the machine architecture. Well, Julia lets you do that as well. The other time you will care is when it comes to precision. Numerical work, especially when you're doing some sort of calculations involving, say, a Taylor series or differential equations, rounding error starts to become significant. So one of the packages, I'll have a quick shot of it later on, it's called interval arithmetic by David Sanders. So if you really care about knowing how accurate your answers are based on the significance you put in to begin with, there are tools available. Okay, so here's another small difference. The caret, Python sees it as a shift, right, to the cubed. You just, you get weird, I'm sorry, not, it's a bit operation, right? So, in Julia, it's the exponentiation. So this is where porting code gets a little tricky. If you put in the double star, it's not going to work. If you copy code back and forth and it doesn't give you a syntax error, it doesn't mean it's right. So you need to actually test your code and have use cases that really exercise the feature sets, just like with the modulo operator. Okay, now this one, right, remember Julia doesn't have a continuation character, so that backslash gets put to good use in being inverse division. So 8 backslash 2, if that was a video moment there, we saw kind of a shaking head there, it gives you 2 over 8. And because it's a single slash, it's going to convert it to a float. And so 2 over 8, yes, is indeed 0.25. 8 over 2 invert is going to give you the same result. All right, you say, do I really need that? Well, it turns out it comes in handy. So a couple other things to look at are how conversion happens. Julia, like Python, has a REPL. It's a fairly nice REPL that incorporates a lot of the features that we've gotten used to in IPython. There also runs inside of Jupyter, so you can do similar kinds of explorations. So here's one that seems a little irritating, right? If you can't take the int of an array, you go, okay, there's something going on in terms of types. Sure, we can understand that. There we get an error, an inexact error. So in the REPL, if I type a question mark, which I didn't do there, but I did do at the Julia prompt, you don't see it, and it automatically converts it into a help. And so I typed in the error, and sure enough, it says type conversion cannot be done exactly. All right, well, that's because you have at least 4 ways of doing conversions. The notion, one of the underlying principles of Julia is know your numerics. Know what you start with, know what you want to get, know what your tolerance for failure, for error, for precision are. And if not, it's going to let you know that you don't know. Okay, so here you have 4 different approaches. Okay, another difference is in how the plus, equal, minus, equal operators work. So this has to do with how the binding of names is done, right? Variables, labels, right? Overriding arrays. These start to become important when you have situations where you have huge amounts of memory at stake. And so if you can do things in place, it's often much better. In place, meaning in place in real memory. Fewer cache hits. And with cache hits, you also worry about things like rows and columns, what the real layout is underneath. All right, so here's a couple of side-by-side examples. And this one shows some of the differences, the idiosyncrasies of each language. Once you understand Python well, this seems to be perfectly reasonable on the right. Once you understand Julia well, it's perfectly reasonable on the left. Right? Where, what happens to the updating when you have shared labels sharing the same underlying value? Yeah. Again, languages are easy. It's the concepts that are difficult, right? All right, so here we have another difference, and that involves how default parameters are handled. So with the rand function, that would be, it's really a judgment call in terms of what you want your function to do, right? It's important that you know what you want to do to begin with. So in Julia, this will always be evaluated each and every time the function is called. It's different than Python, where it would get evaluated once, and that becomes the default throughout, when used in the function. Okay. I may try to do a little live demo, but those always seem to have glitching, so I'm just going to run through this and we'll do whatever we can live later on. Okay, one more change. Python, it's a two-letter. I'm not quite sure that I like the idea of using two letters. And you certainly cannot put a space in between here and here, which also is a little bit of an aggravation at times because you want to have readability, right, of your code. But these are what the requirements are. All right, so the world is divided into people who go like this and people who go like this, right? Depending on how your data is organized, that's how you want to organize your code, right? That's the bottom line. Which way is numerically going to be of most interest? Is it going to be along the rows or through the columns, right? You want to reduce cache hits as much as possible, right? When you're looking at arrays that are not merely 1,000 by 1,000, but maybe 10,000 by 10,000, right? This starts to become a very challenging problem. Okay, so Julia also has the notion of horizontal and vertical, and transposes, and then these little dot operations as well. So let's do a couple of examples. Now there's not any difference here between the comma and the semicolon in this context, but we can see that the space gives me a 1 by 3 array, and the commas or semicolons gives me a 3 by 1. Right. And sure enough, that's a double equal there, a little hard to see, but it is. And the types, right, these are arrays. It defaulted to int64s. I could have specified that it be, yes, is there a question? The two? Oh. It should be the number of dimensions. Yes. Yeah, because it's an array, not a... Right, so that first dimension, right? Okay, let's see. Okay, So here we go. And there's a more convincing case of it being a two-dimensional array right there. The 3 by 3 versus the 1 by 3. And here we have this backslash again. Right? And this is where it becomes more than just a trick. It's a useful trick. So what I'm trying to do is solve this system of linear equations, a 3 by 3, right? A times x equals y. And it says, nope, not going to work. So we have tab completion. And over here I see something like determinant. And I plug it in here. Now there's a lot of stuff that comes pre-bundled in with Julia. So while there are the notion of importing modules or packages, in Julia we will add packages and then use the package. It's a little different than Python in that case. In this case, determinant's built in. Anything to do with basic matrix operations, like inverse, trace, determinant, is already there. You don't need to do anything extra for it. And here's our problem, is that the determinant is 0. So I'm going to go ahead and just change one element there. Now I have a nice happy determinant. I'm good to go. And I still have a problem, right? Okay, that's because y is pointing the wrong direction, right? Do I want y to go like this or y to go like this, right? All right. So that apostrophe at the very end, I have a mouse here, right here. This apostrophe is shorthand for transpose. And now I get my solution, right? So it's nice and compact in that. And you can build on these. So multiplication of arrays, right? There's a 1 by 1, right? Multiplying it this way I guess, or multiplying it this way, right? You know how it works with matrices when you multiply vectors, yeah.
Is that a free operation like in NumPy where the transpose is just attached to metadata and changing between row and column major, or do you actually need to do a copy every time?
You have your choice. There's a whole library. I would have to check to give you an answer for this instance. But it's just one of the things that Julia has been taking. They have like 30 or 40 different methods that you can use with almost every operation to make them smarter. So here we're multiplying our matrices, creating a random array, an invert, getting the eigenvalues. So one of the creators of Julia is Alan Edelman, and he's a faculty at MIT, and he's basically king of the eigenvector. And so that's part of what informs a lot of what went on in developing Julia. Okay. So now there's Julia Box, which is part of Julia Computing. It's kind of like Anaconda, Continuum Analytics, where they have a free setup, Miniconda, and then they have their commercial enterprise. So Julia Box is Julia Online. And so here we go, some examples from that. And again, might try to just play with this a little bit towards the end. Okay, and here we have, those of you who like looking at Linux, a little more of that. All right, so I'm going to run through a bunch of these. I'm just wanting to give you a flavor of what's out there in terms of Julia land. There's also Juno, which is built on top of Atom. You know, it's your editor of choice, right? Whether that's Sublime, or if you want to use some more of an IDE, right? VI, Emacs, whatever floats your code. So this is all run inside of Atom with the Julia. So the package system in Julia, while there, I think where's the number of 1,400? Last time I checked, there are over 100,000 packages in Python. So it's good and bad. 1,000, 1,500 is probably still too many to claim expertise on, or even awareness of what each of those do. One thing that is interesting is that there is some testing built in to here we have a fail. So this is 6 months ago. Julia just got released, version 6 just got released a week ago. So I wouldn't expect all packages to pass. And the passing is only as good as the testing. So you can't just rely on that it says pass. You actually got to see what it is that it's passing. The breakage between 05 and 06 for people who've invested, like say the FAA, which has this big aircraft collision avoidance system that's written in Julia, they probably aren't going to port to 06 that quickly. Right? These things move at the speed of government. Here's interval arithmetic, deep learning, Bloom filters for probabilistic, lots of stuff out there. And Gadfly is one of the packages that was written specifically for Julia. And you can get plots out there fairly nicely. This is the iris data that everybody refers to. Okay, gallium debugging, right? Doesn't take much to get complicated enough that you hope there's a debug around, and there is. And there's a great talk. I love the hand gesture there. That's Kino, one of the major contributors, core committers, but not one of the creators of Julia. And this is from last year, so it's fairly recent. Okay, Python has a dis function, right? If you want to see what's underneath, what the bytecode is. So Julia will give you what the native code looks like as well. And this will be of interest once you start worrying about having a piece of code run overnight, right? As opposed to, can I get it in an hour? Or if I can get it in an hour, can I get it in a minute instead, right? So when you start getting into performance issues, you'll probably go down this road as well. Okay, so packages get added to Julia. They can also get removed from Julia. So this is from your workspace. So think of it as what Conda might do or pip when you do a pip install. Right? You haven't really done anything with the code yet. You're not using it, but you are prepping the system for it. And so Jump does mathematical modeling, all sorts of cool things. So if you wanted to add the Jump package, which isn't built in, it's going to go out there and fetch it. So you need an internet connection most likely. And if you look at the Julia blogger's log, he goes through a use case of solving the fish riddle. Very cute. So that's me. Let me do a couple of other things while we're here. So the first thing is I wanted to figure out what I was going to talk about. And so let me just make this full screen. Here we go. And oops, no, I don't want to picture this. Maybe I do. Let's try that. I have one of these giveaway hide your camera thing. Here we go. All right, so yeah, I know this is backwards. That's because I'm left-handed. Okay. I bought a right-handed Mac by mistake. Okay, so this is my mind map of what I needed to talk about, right? The IDEs and the type system and the dispatch and high-performance computing. Yeah, so being the only Julia talk meant, that's not going to be. So this is just the type system, right? This is the abbreviated version of everything that goes on in terms of Julia cleverness. So you're welcome to reverse the image and use it as you like. Let's clear this away. Okay, so let's just do a little bit of a tour as to what's going on here. So if you're going to work with Julia, you want to figure out, you want to get very friendly with the Julia website. And here's just an automatic demo that comes on the Julia blog showing you how it might work in Atom. Let that run for a little bit. Let's just let that run on the side there. Okay. And let's see if I can actually get this Julia Box tutorial to run for me. See if I can connect here. Okay, connecting to the kernel. So this is Jupyter. You're all familiar with Jupyter, and you can see that there's lots of that may or may not be talking. Let's see if that works. Okay, very good embedded tutorials inside of the documentation about types, more about types, a nice post about the difference between, this is in the Haskell log, about the difference between Julia and Haskell in terms of the type system. I can recommend that. You really want to know about MATLAB differences, R differences, C++ differences from Julia, right? It's great for anyone who wants to port. Okay, here are the notebooks from the online course that's available. So if we look at, say, the type system, right? So this is not live in the way that Julia Box would be, but it's on GitHub, and you can download it pretty easily. It's a nice little course, and it's intended to be a course for true beginners, not people who are coming from Python or coming from R, people who are just coming to coding. Might be a little ambitious. Even in Learn Python the Hard Way, in the introduction it says, no, this is for people who already know how to code. A nice little cheat sheet. Oops, here we go. This is from a course given at MIT. I believe everything on here is still valid in 06. The essentials. The whole notion of what's equal and what isn't. So Julia and JavaScript do have something in common, the triple equal sign. Right, is, in other words. Writing good Julia functions. Well, performant is the first word. Type stable is the second, and legible, well, that's in the eye of the beholder, you know. Lots of stuff on the Julia computing blog. It's not just marketing materials. They do have some pretty good introductory material. This is a set of slides. Sorry. Let me skip over this for now. So Flux, this is a contribution from the community to do machine learning. In Keras, like fashion. Not connected, okay, let's see. I think my best shot is to come in here, maybe start over again. Now the thing with Julia Box is you need to sign up for it and have a password. There's no charge. They do have a nice tutorial on the 05 highlights. Hopefully they will have one on the 06 highlights fairly soon. And here it is actually, you can run live in Julia Box. Right. So here's what happens when you add a package. It's cloning, right? So it's bringing it down from GitHub. Now the first time that you use a package, it's going to be compiling it, right? It's a bit more intense than what importing a module is in Python. There's some work that gets done, of course, with an import. With using, it actually compiles it to your machine context. Okay, let's try restarting this guy here. Okay, GPU arrays, right? That's another aspect of high performance computing, is whether or not you can tap into your GPUs. Here's a talk given just a couple weeks ago by David Sanders on the 1.0 story. Again, it also has the Julia notebook available. So again, a very useful notebook to look at. Some blog stuff here. Let's see if we have, oops, no kernel. Here we go. Are we live? So just like you'll recognize the asterisk as telling you that it's thinking. But I think I'm going to have to just restart. How are we doing on time? Okay, let me try doing something else here. Okay, so here is here we go. Okay, so here is a local notebook that I have. Okay, so I got this off of one of the Julia posts. And let's see, are we still live here? Yeah, there we go. Okay, so this is local to my machine. Here's a nice little function. Now, because I already added the package, I already used the package once, it's much faster, right? using Julia on small sets works pretty well. What is still slow is doing the importing, right? Because it's doing compiling. So it's doing all the compiling you're going to use 100 billion times, but it's going to do it all up front once. And so there's going to be a time penalty on that. So let's see how far we can get here. So somebody came up with a mathematical formula that when you plot it, it replicates the formula. It's called Tupper's equation, and it's just a clever toy trick. Okay, so you can see you get a lot of information that you may or may not want. So here we are. Package update, oh, that's going to take a while. It's going to rely on the internet, and so that'll wait also. Okay, I'm just going, oops. Okay, so let me, oh, here it is. Now, one of the challenges of doing very large projects is sometimes your underlying code changes, and you don't want to restart everything. So there are some modules out there, packages out there, that will let you reload packages. Again, use with caution. All right, that's going to cook for a bit. Let me just see if I can minimize this. Here we go. All right. Okay, so here is the textbook that I mentioned earlier. It's pre-publication. I'm one of many reviewers of this. If this is something that appeals to you, shoot me an email and the idea is that you read it in exchange for commenting on it, okay? So Michael Kochendorfer, he's at Stanford now. He was involved with the FAA project at Lincoln Labs using Julia. And what's really nice about this is all the Julia code that is embedded Let's just go down. Here we go. Okay, so those of you who are really into gradients, right? So this is the math that most people are happy to step around when they're doing machine learning. So here it is in Julia. And this character and all the Greek characters, alpha, betas, you can access those by just putting in a backslash and a tab. And let's see if I can quickly demo that. We'll try that. Okay, so any last minute questions? I think it's time for lunch, more or less. So there, right there, you saw me create an alpha
hello?
there.
Oh.
Yes?
I'm just curious about what is the interoperability story for Python and Julia?
Well, I think it's similar to the interoperability story between Python and R. It exists. It's possibly a bit more robust because of the tightness that Julia has with Jupyter. Okay. So while Julia is informed by MATLAB and RStudio, it's really in the Jupyter camp. So the kernel is much further along. There are, you can use PyCall pretty easily in Julia, and there are a lot of wrappers available. So you actually can access matplotlib and things of that sort in a fairly straightforward fashion. Okay. Anything else?
Quick one here, thank you. Given that package management is done from within Julia itself, what is the support for environments?
Which kind of environments?
Like a virtual env kind of thing.
I don't know offhand. I don't know. I know that the package system, there's a talk at JuliaCon about the upcoming package management system. But that's an excellent question. Yeah. I have a dozen Conda environments for Python. I just run Julia in one single environment in my box. Typically, if you're going to be doing Julia work on a cluster, right? But still, you're going to want to have some sort of sandboxing available. So, anything else? Okay, so I think I got about 1/3 of the way through the material I would have liked to have touched on, but I'm happy to answer questions, and let's see if I put my contact info up here again. Oops.
And just very briefly, lunch is starting outside, so feel free if you need, but you guys can take the room for questions. You're not blocking anyone, so feel free to take your time, and thanks again.
Thank you.